Yeah, that's one, and I'll note that down. And is there anything else? So, if you guys have any other thing that you would want me to discuss in basic
Sir,
Python before we, yeah.
sir, reading the basic data sets like netcdf, some dat files, or
Yeah, so
those
that we will cover
information.
in Xarray. You don't worry about that. So those things will cover in Xarray.
Okay.
And
And
so
some
I will,
basic.
yeah. That's something I will cover.
Okay.
So yeah, is there anything else apart from that?
Sir, we will let you know.
Okay, thanks. So I hope you guys are comfortable with Jupyter notebooks by now, right?
Yes,
Yes,
sir.
no?
Yes, sir.
Okay.
Yes.
Yes.
Okay. So yeah, so I maintain this Python class repository, and there are some stars and forks to it. So I keep putting or pushing stuff here which I feel can be reusable. Like for example, yesterday I pushed in. So how if you have two data sets and you want to select common dates, so which is like it took me quite some time for the right implementation, but then I just keep pushing stuff here, and you can use these codes at your like for your uh, work. And so like so I don't know the name of the person who asked the question about define function, but so
Sir, it's
one
Nikhil.
thing is, yeah, Nikhil. Okay. So Nikhil, this one, as you can see, so there is this course on convolution neural networks for visual recognition, and they have they have this Python NumPy tutorial. This is like very exhaustive and it covers a lot of things. So what is it in define that you don't understand? See, we have just like Fortran subroutine, we have the def keyword, we have the name of the function, we have the arguments, and these are having, so this would be having a local scope in the function. Have you guys been taught classes and objects?
Yes, sir.
Okay. So yeah, I mean depends upon where the function is defined, whether it is a part of the class. So then it's very important to use this colon keyword, and like anything else in Python. So the syntax is, so if anything that is within one tab after this syntax, it would be considered a part of the function. In Fortran, I think you would use curly brackets, right? In Fortran subroutines, if I'm not wrong.
No, sir. It is simple normal bracket.
Yeah, so these are functions, subroutines. Yeah, so okay, yeah, so you would not use bracket. Rather, I think yeah, in C++ you would use brackets. But in Fortran, what you would typically do is you would say subroutine, and then the name of the subroutine, and then you would say either say end, or you would say end subroutine, and then you can give the name also. So that's how it works in Fortran. Similar to that, so here in Python, you don't have to say end function or end something. Python automatically understands that from the point this, like, it doesn't encounter the tab, so it would understand that that is no more a part of this function, and you can return values from a function. So you can use the return keyword. Is there anything specific you are not able to understand, or like, is this clear to you?
Sir, while creating any module, people generally generalize the this function. So I didn't understand how to generalize the formula or any function.
What do you mean by like you didn't understand? So this is like any function is a generalization of like whatever formula or whatever repetitive code you have to use, right? So for example, this one is doing a quick sort. So it is inputting a NumPy array, and it's checking whether if the length of the array is less than equal to 1. So if there is only one element, you return that particular number. So then you don't need to do sorting. And if you are having, let's say, more than one numbers, so then you would find out pivot. So this algorithm basically works in a recursive manner. So you can see it's saying it finds the pivot, which is the centermost element in the array, and then it would divide the array into left, right, and middle. So left is x for x in array if x is less than pivot. So basically you push all the so you so from the indices, okay, so like if you have 10 numbers, you would see the you would see the fifth number, and then you would create a list left, and you would push all the numbers which are less than the element number 5 to left, and you would push all the ones who are more than pivot to the right. And if the pivot is also and the middle will be the pivot, and then you say return quicksort left plus middle plus quicksort right. So this will recursively then generalize, and so until it reaches the so until this quicksort reaches the stage wherein the number of elements in the array becomes one, it would keep doing a recursive operation. And at the core of it, so if you think of it in terms of like if there are three numbers, right? So then it will pick up the second one as the pivot, and then it will push the lower number to the left, the higher number to the right. So the smallest basic version would be a sorted array, right? So it would sort in recursive. So what is it that you are not able to understand, in like that Python function is not able to generalize?
Sir,
Or
one more question there, that the return array, this return value is passed to which variable actually?
that depends upon you. So see Python, see here, for example, we are printing the output of quicksort. You can return it in a variable or in a list. So it returns a list. Okay. So Python, you don't need to define the variables. So it just automatically understands, okay, so whatever value it is getting, the data type will be that. And so you can pass it to a variable, or you can just directly print it.
Sir,
So
inside that function, suppose I want to pass that value to a particular variable,
which
then
value?
suppose here is return ARR. Suppose
Hmm.
return ARR, I want to pass to suppose any variable A, B, or C inside that def function.
Where?
So
Here?
third
Hmm.
sentence. So
Third one.
uh,
Okay. Okay. Yeah.
third sentence, yes, return ARR. That
Hmm.
ARR value will get written, right?
Yeah. Yeah. But only
But
if the length of the array is less than equal to one. So only if there is only one element remaining in the array. So you
but I
can see
want
what this process is doing is it is basically reducing the size of your array, right? So it left, right, and middle, like then recursively, if you pass left to the quicksort, it will again go here, and then it will again break down left into left, right, and middle. So it will keep doing that recursively.
But I want to
So
pass that value in a particular variable.
you want to pass that? Yeah, you can do that. No, see, you can just save this. You can just say maybe some variable equal to this entire thing, okay, and this is basically a list, and then you can say return that list.
Okay.
And they are they are uh, they are making it concise by even not using that particular list variable. Yeah, you can do that. That is not something which is an issue.
Yeah.
Okay. So Nikhil, are you clear with the functions?
Yes, sir. I think I need some more practice with different.
That is, yeah, that is true. I mean, with, yeah. So okay, so we will today go through the toy example of Xarray, and let me do one thing. Okay, we'll go through the official documentation. Now, if you want to, so Xarray is a Python package for handling different kinds of data sets. Like, it's very useful for handling three-dimensional or four-dimensional data sets, and it has got lot of functionalities and lots of uh, features from different other packages like pandas, like Dask, NumPy, and it is, so you can very easily, if you know pandas and Dask, so you can very easily switch on to Xarray, and Xarray like makes your, if you learn it nicely, it will make your life very easy. And so Dask is for parallel programming, and you don't need to do anything special in Xarray to implement Dask. So Dask is a like separate language which basically helps you do like you divide your data set, and then you can do different things in a, if you can use all the cores in your compute. Okay, so now to set up an Xarray environment, that is to install that. So you should be aware that, yeah, no. So for setting it up, they don't have that or what? Yeah, so just wait. So the way you, like, you should typically install Xarray is using Conda. And if you do Conda install, yeah, Xarray Dask netcdf for bottleneck, and you should also parallelly install Cartopy and PyNIO. Like, you would typically get almost everything that you would need for your analysis, for plotting, for like different stuff. So that is on installing Xarray. And I would suggest, like, if you're doing some kind of basic level of analysis, then okay, sorry, that then you should do it mostly on Collab. Like, it's easier to manage, and otherwise you can create your own environment and work in that. So we can see that, so this is just a simple hello world example that they are showing. And now, so you can see that these are the examples of multi-dimensional data sets, these cubes. So you can have different variables: temperature, precipitation. One face here represents latitude by longitude, and this H here represents the time. So you can have the data saved in hourly or daily or monthly, yearly, even sub-hourly, depends upon your application. Now, if you are yeah, so there are a lot of things. Yeah, these things we'll discuss later. So there are two main data structures in Xarray. One is the data array and another is known as the data set. So data array is basically, you can consider it as a single variable, like maybe a three-dimensional variable. But Xarray comes with its own set of like this data array is a class in Xarray, and it comes with its own set of things like coordinates, dimensions, attributes. So there would be a global attribute for a data array. There can be an attribute for a particular variable, a particular dimension. So that's that's like the data array is the most fundamental or core thing in Xarray. And data set is basically a combination of different data arrays. So you can aggregate the different data arrays in a data set. And so yeah, so data set would be like consisting of either one or more than one data arrays. So to basically make a data array, so this example is showing how you can make a NumPy array into a data array. So we will run. Shall we run this here? Okay. What I will do is I will just bring this here. And do they have collab? Oh, they're saying they have, you can run this in launch binder. Hmm. Yeah, so it is still loading. So you can see that we have we are importing a NumPy array, NumPy library as NP, and we are also using a particular seed as 0, so to basically reproduce the results. And a data array, so this is the syntax how you will create a data array. So the first thing that you give is you can make it from a NumPy array. So you can see that we are making a NumPy array of size 3 by 4 by 2. So it's a three-dimensional NumPy array, and we are saying that the names of the dimensions are x, y, and z. So we are saying dims equal to we have to give this as a tuple. So, and what is the name of the data array? So you have to give the keyword, the name of the data array in the as the from the keyword name. And then what are the coordinates? So dims and coordinates are typically might sound the same, but they are different. So if you don't pass coordinates, you would have the dimensions, but those dimensions would be not having any values. But if you pass coordinates, so coordinates basically mean, so you are saying that, okay, so here the last dimension is z, and so this one has a shape of 2 in the last dimension. What are the values of the z coordinate, okay, or z dimension? So that you pass in coords, and then you also, so they are also passing this coordinate u, which they are saying is, okay, so the coordinate is u, but it corresponds to the dimension x, and you see in x we have a size 3, right? And then the attributes, so these are the global attributes of the data array, and the name of the attribute is attr, and it is, so we basically generally pass a dictionary, so we pass a key value pair. So I will, maybe we can run this and you can see. So if you print this, so it looks like something like this. So you see it's a is a, so you da is a Xarray data array, its name is a, it has 3 dimensions x, y and z. These are the sizes of these dimensions, and so this is the, these are the values. So it's looking like, you can see these values because it is relatively smaller size of 3 by 4 by 2 only. And then you can see the coordinates here. So we have defined 2 coordinates, z and u. So u is having a dimension x, so you can also have directly have a coordinate as same as the dimensions. So you can click on this and see the values of these dimensions. So you see here, if you click, you can see the values. And then this data array has got a attribute value. So it has got one attribute, and the value of the attribute is value. So like the value string. So this is just a dummy example. And here, see, they are explaining here, we use a 3 by 4 numpy array, values belong to 1. And so you can also you can also define a data array like this. So you can just say that give the values, and you say what is the dims. So typically you should remember that 1 2 3 4. So if there are 4, like I would say 5 important arguments that you need to pass to a data array. One is the values or the numpy array, then you have the dims, which is a tuple, then you have the name of the data array, then you have the coords, which is a dictionary, and then you have the attrs, which is the attributes. So that is about data array, and you can print it. So you just have to say, like, just have to just give it like this, and it will print the data array. Now there are some things which you can do with this data array. So if you want to print the transform this data array into numpy, so you can say da dot data, or you can also say da dot values. Okay, so so the data function will return you the, or the values function will return you the numpy equivalent of that data array. Now, if you want to know what are the dimensions of the data array, okay, you can say da.dims. If you want to know what are the coordinates, you can say da.coords. If you want to know the attributes, you can see these are the attributes. So you pass the dims as a tuple, coordinates and attributes as dictionaries. Okay, and then okay, so you can see this is another example wherein we have a 2D numpy array. So you see np.1 3, 4, and so these are the dimensions, these are the coordinates. So here they are defining the coordinates x, y, and also another coordinate as u. And you can see that how this data array looks like. So you have the numpy array, and then you have the coordinates. We have not passed any attributes here, so attributes is showing as 0. And okay, so now he says, so there is an exercise: create data array named height from random data with the dimensions as named latitude and longitude. So how would you make this? So you would say, first say height, and then you would say dims equal to, so we'll copy from here, dims equal to latitude and longitude. And you can see that, so this is a this numpy array has now been transformed into a data array with the dimensions as latitude and longitude. Doesn't have any coordinates, doesn't have any attributes.
Sir,
Now it's saying, yeah.
s- in the earlier example, not
Hmm.
this one, just before that, so it's a two-dimensional data, and there are three set of coordinates. Is it like that?
Yeah. I mean, that is like you can have. So it's like it's like you are having latitude and cosine of latitude as well. So for some applications, if you need that, or for some, so you can have in a data array. So or like if there are multiple such data arrays, so some of them might use the latitude, some of them might use cosine of latitude. So it's a like generally good practice. So this is not very common, so they are showing it just for, I think, demonstration purposes, that okay, so you can do this as well. But generally you won't see people do this a lot. Mostly what you would see is that the coordinates and the dimensions would be same. But you see here he is not adding any extra, you see. So here this u coordinate is same as like x. Okay.
Okay. Yes, sir.
Yeah. So you can do this as well. I mean, it's not compulsory, and it is not very common as well. Okay. So then he's saying that, okay, so with dimensions, coordinates, so you would say your first this numpy array is height, and then you can pass the dims equal to, so we can copy from there. So you can say dims equal to latitude comma longitude, and then you can say chords equal to, so you're having your latitude, and latitude is basically np dot arrange minus 90 to 90, and then they're saying that your longitude has values from minus 180 to 180. Okay, so you can see that here we are having, now we also have the coordinates. The coordinates are latitude and longitude. We also know the values of these coordinates, and these are the same as the name of the dimensions. So you can see this, the entire data here. You can click on this and see these values. So then if you want to add some metadata for both the data and the coordinates, so what you would do is you would say height, and then we'll bring this from here. So we'll say dims and chords, and then we would say, so the height has a type ellipsoid. So you can see how to add an attribute to the data array. So this is the way you would add an attribute to the data array. So you would say, yeah, attr is equal to this one. So you would say, so you can say type is ellipsoid. Okay, so this adds the attribute to your height. And now they're saying that latitude and longitude also have these attributes. So we had seen how to add attributes to the coordinates as well. So if you are adding an attribute to the coordinates, so in that case, yeah, we'll try this one. So okay, I'll show you another method to add the coordinates as well. So this one, now you have, you can pass it as a tuple, and in this tuple the first is the name, the second is the value, and then the third is the attribute. So the attribute for latitude is this one. Okay, and then same thing we will do with longitude as well. So we will say, so now you can see that if you have to pass it as a with the attributes, then you would pass tuples, not just dictionaries. So okay, it's saying that this is invalid syntax. I think we did something wrong here. So we need to pass the as a dictionary and unhashable type. Okay. So what we will do is we will yeah. So this one is our we'll see that I will show you how to add attribute separately. So yeah, so we will add the attributes to our coordinates as well. But if you want to add, I think, attributes to your variable height, then that's easy. You can just say, yeah, so you can just say this. So then we have the dataset. So dataset is basically, it will, so you can see that it has, so this has two, you have the first keyword as data underscore vars, and in data underscore vars, so this is so this has got two data arrays. So this is the first data array A, and you pass a list, you pass a tuple to it. In that tuple, so first tuple you pass it as the dimensions, and then you give the values. So what is the value of that data array? And then second is the data array named B, and it has got the dimension of T. And so you are passing this value, and then you are also giving the attributes, and you're saying, okay, so that the coordinates are, so you are just giving the x coordinates, and you are giving the attribute for the entire data set. So you can see here, so you have the coordinate defined as x. You have the data variables a and b. So a and b are your data arrays. So you can see, you can access your data array as, so you can just say in fact you can access anything. So you can say ds.x, So this is also you can access. You can say ds.a. You can also say a square bracket, and then you can pass this as a string. So that's how you can access, but we will see. Yeah, okay, so this is a data set, and yeah, this is how they're displaying it. Okay, so now with the as with data set, data array data set becomes really useful once we assign the coordinates. So here we would see the time coordinates. So you see we are also assigning this time coordinate. So we are bringing this from pandas. We are saying pd dot date range. You start from this time. What are the total number of periods? That is equal to 8. So you can see that this is having so b is having a dimension of t and x, and it is having a size 8 by 3, and the frequency you can say it as days. So frequency equal to d. So you can see here now this dimension is so Xarray datasets or data arrays, whenever you use time, so it's very easily it very easily understands the pandas time time data type. So it's better to use that. And so you can see here, so it has passed so it has created this dimension time or this coordinate time, and we have not defined this as a dimension. I think it's just a coordinate. Oh yeah, it's there as a dimension, sorry. Yeah, it's there as a dimension. And then so you can also do different things like, so xa is np dot arrange 1 to 4, xp is np dot arrange minus 1 to 3, and then you can create a data array. You can say, okay, so what are the values? You can pass the dims and you can pass the coords. So these are the coordinate values. And then this is another data array. So with the coords as xb, and then you can say you can merge this these two data arrays a and b into a data set, wherein the data vars, it will be a dictionary. So you can see here also data vars is a dictionary, and this dictionary data vars will take in the name of the data array and the actual data type. So here we are having this exercise saying create a data set with two variables along latitude and longitude, so height and gravity anomaly. Okay, so how will you create this? So you would say data vars equal to, okay, and then you will say height. Okay, so let us see how they were creating this. Okay, so we will make it easier. We will use this one. Okay, so this is a data array with height, numpy values as height, and then we will pass the dims as so latitude and longitude. And so they did not mention anything about coordinates, so let us remove that, and we will add another data array here. So oh, I think I did some mistake here, so it should be in quotes. Okay, So you can see here they have so this code has made, okay, this has generated a data set with dimensions latitude and longitude. The coordinates are, I think there is some issue with this. Yeah, I think we should have done it this way. Okay, so you say height, say gravity anomaly, and then the dimensions are latitude and longitude. And the NumPy arrays are height and gravity anomaly. Okay, let us see this now. Okay, so we have got, I think previously were we doing fine. Okay, so we will do one thing. Yeah. Oh, yeah. So this looks fine. So we have the data variables, or these are the data arrays in this data set, height and gravity anomaly. So these are the values, and it has got two dimensions, latitude and longitude. So now they're asking us to add metadata to the coordinates and variables. We'll see how to add metadata after creating the data array or data set. So then they're talking about so data set and data array objects are frequently created by converting from other libraries like pandas, or by reading from netcdf or Xarray. So these are the two file types, netcdf and Xarray, which are most frequently used. And to convert from or to pandas, we can use to Xarray method on pandas objects, or to pandas methods on Xarray objects. So just like we can convert from Xarray data array to a NumPy array, so you can say dot data and dot values. So the same thing. So for example, this is your pandas series with with 10 numbers. All of them are one. And then your what is your index? We have defined the index, and then we can very easily transform this into a Xarray data array. So you will just have to say to Xarray, and this transforms into this one, and then the index becomes your dimension, or the becomes your coordinates, and the dimension as well. Yeah, and then the values of the index, you can see it's taken as this. And then very easily you can convert this ARR to pandas series or pandas data frame, depending upon whether it's just one column or two columns in the pandas data frame. And you can also control what pandas object is used by calling to series or to data frame. So you can see that we created this Xarray data set here, which is having two variables, Xarray data arrays A and B. So A has the dimension X, these are the values. B has the dimension X and Y, and these are the values. So if you want to transfer, you how you will you access A? So you will say ds.a, and to transform this to pandas series, you can just say dot to series, and then you can see what is B. So B is this one. It is a two-dimensional data array. You can just directly transform it to pandas series. So then this will transform into, so you will have, these are the two indices of the pandas series, and these are the values. All of them are one. And then you can also say to data frame. So you can just say to data frame, and this has transformed this into a data frame, and you can transform the entire thing into a data frame. So you see you have a, b, x, y. So and then we have the IO basically, which is the input and output to and via like reading and writing from or to netcdf or grib files. So grib is gridded binary, and we have the zar files and the geotiff or gdal rasters. So we'll see this now. Okay, so now you see we are having, okay, so we are having this data set ds1, which has two data arrays a and b. So these are the data variables, and the dimensions are x and y, and this is the value of a. And then we are also defining the coordinates here, and we are having another data set ds2. So you can see we are defining the data variables, we're defining the coords. Now to write this to an HTTF file is very easy. You can just say that particular data set to underscore netcdf, and then the argument will be the name of the file that you would want to write. And you can also say ds2.netcdf, ds2.toNetCDF, ds2.nc. You can also write a particular data array. So you can say ds1.a.to underscore netcdf. So you can see that now this has created these files da1.nc, ds1.nc, ds2.nc. And reading is also very simple. So you can just say xr dot, so xr is from, so we said import xarray as xr. So you can say open underscore dataset, and you have to give the name of the file. So you see we created ds1. So ds1 is this dataset. Okay, you can also say open data array, so it will open that particular data array. Now this is a mistake that a lot of people would do. Like you would have save a variable, save something as a data array, open it as a data set. Okay, so in that case what will happen is, yeah, so you see if you do this, then only you get this data array. Otherwise I think otherwise also you can get, but it just, it used to change the name of your data array. Yeah, it's still reading. Yeah, in this case it's still reading, but sometimes it would show some issues. And then we have, just like netcdf, we have a zar file format. So zar is a Python package and data format providing an implementation of chunked, compressed, and dimensional arrays. It has the ability to store arrays in a range of ways, including in memory, in files, and in cloud based object storage such as Amazon S3 and Google Cloud Storage. Xarray's ZAR backend allows Xarray to leverage these capabilities. So now to write a particular data set to a ZAR file format, you will say to underscore ZAR, and you would give the name of the file, and then you would say the mode. So mode can be reading, writing. So we are writing. So you see here it has created a ZAR file ds1.zar, and the mode is write. And so you can also, so it's saying or to any mutable mapping interface. So yeah, I'll need to see what this is. But if you want to open the, where have you defined my store? Okay, we'll see this, what this is. But if you want to read the zar file, so you can say open zar, and you give the name of the zar file. Now this chunks is a very important keyword. So if your data is huge, then you should always use chunks. because what this will do is in the backend, Xarray will divide the data across the processors, and that is typically people would use Dask library, but Xarray will do it. Will just do it for you without any extra effort. So that was on the data structures and so data structures for multidimensional data. And if you have any questions, you can ask, or otherwise we have 8 minutes and we will move on to the next notebook that they have provided in the tutorial. Is there anything specific you would want to?
Hello, am I audible?
Hello? Yeah.
Yeah, so I am actually get confused with the dimension and the coordinates. So what is the difference between dimension and coordinates?
Okay, so see, the difference between dimensions and coordinates is like, see, you should always have a dimension, okay? But it works if you don't have a coordinate. So coordinate is basically, typically coordinates would be same as dimensions, but with the so your dimensions would be having some values as well. So for example, latitude, longitude, time. So you would know at what latitude and what longitude. But if you don't pass your coordinates, then you don't know the values, or you don't have the data in your dimensions. Now, adding to that, the additional feature of your coordinates is that you can also have a transformed type of coordinate, or like some kind of, for example, in global numerical weather prediction models, or in any, even if it is not global, even regional model, the vertical height is sometimes it will be in pressure levels, sometimes it will be in hybrid pressure sigma levels. So you can use this coordinate, you can use the coordinates to make different types of you can make different types of grids. So you can think of these two as similar, but with coordinates having much more features. You should always have dimensions defined. I don't know if it will give error if you don't give the dimensions, but don't forget to not give dimensions. So, but coordinates is also like, yeah, I mean, if you are working on real world data set, then you should give coordinates as well. But there is a very subtle difference between them, in a way that the dimensions are just names of your, for example, axis. So like here we have x, y, and z, whereas the coordinates are not just the names, they are the names and the values. So you can see we are passing the dims as a tuple and the chords as a dictionary with key and value. So the key is the name of the dimension, and the value is the are the values of the, or the of that particular axis. Is it clear?
Little bit. So if you just output dimensions from this data array, so it will just give you the name of the dimensions like x, y, z, or it will also give you the values.
Can you come again?
I'm asking if you output, or I don't know, if say you create a NumPy array of this x dimension, so and you get that values from x array to NumPy. So if you just extract the dimensions, will it give you the values
Yeah,
also?
you can see, you can extract the, we'll see, you can extract the dimensions. You can say da dot dims, you will just get the names. Okay, you can
Yeah.
extract a particular dimension also. You can say, okay, you can say 0, or you can say 1. Okay, typically how
Okay,
would
so
you how you would access stuff, and you can also access the coordinates.
no, I'm
So, or
asking.
you
So
can say dot,
you
you can say dot. So coordinates, once you define the coordinates, you can access a coordinate as a variable of a data set. Okay, you can just say da dot g. Oh, it's not there. Da dot x. Yeah, x is there. Okay. So yeah, they have x but not c. Oh. We
Okay.
need to run this first, I think. Yeah, wait. So da.z, yeah, we have this. Yeah, I think it was some previous thing. So you see now you can, once you define coordinates, you can use a coordinate as a variable, or it's like any other data array in your data set.
Okay, so this z is coordinate. It is not the dimension z, right?
Yeah, this is the coordinate, and it has also got a dimension which is z. You can see here.
Yeah. So is it good practice to keep the name of coordinates and dimensions same?
Yeah, generally that is only done. You would see latitude, longitude, time, levels. Those are the names of the dimensions, and coordinates are generally kept same.
Yeah, so it will avoid any other ambiguity.
Exactly.
And I have
Yes.
another question. So what is
Hmm.
exact difference between data array and data set?
See, that's what I said no in the beginning. So data array is corresponds to just one variable, but data set can be a collection of many data arrays, or it can be even just one data array.
Okay.
Okay.
That that means, sorry, I entered the class late. Does that mean that data set have, I mean, data array have only one variable, or it can be multiple variables?
Yes. Data array only has one variable. Yes.
Okay, and data set has multiple variables.
It can have one or more than one.
Okay, okay, thanks.
Is there any other question?
Sir,
Yeah.
suppose that in that latitude and longitude that you shown,
Okay.
the values, suppose I extracted the latitude values from it and I modified it in my own way.
Yeah.
Yeah, after a modification, I want to update that latitude and latitude or
Yeah.
longitude again. So how one should update it?
That is very easy. Wait, I'll just show you how to do that. So, for example, here you say ds equal to this data array. Okay. So now this data array has got latitude and longitude, right?
Yes.
These are the latitudes and longitudes. Now to update these values, so what you will do is you will say ds, and you will say latitude, for example. So first thing is latitudes and longitudes are also are coordinates, so you can treat them as variables. Okay, so you would pass a tuple, and then you will pass another tuple in that, and you will pass the dimensions of that particular variable latitude, or the coordinate latitude. So latitude has what is the dimension of latitude? It is latitude, right? And then if I can change so I can say maybe from it went from -90 to 90, right? So I can say that it should go from -70 so to what it will be. So you add 20, so you subtract 20. How much will that be? So this is okay. So let's say 0 to 180. We give 0 to 180. Yeah, because see, you cannot give just some any other number. Okay, so it's very important. I will show you. So if you give 0 to 190, okay, this will give you an error, because your dimension latitude and your is having, what is its size, 180, but what you are passing as 190. So it will, so those are the things Xarray will do for you. So you see now we have changed the value of the coordinates. So you see now latitude is 0 to 179. Okay.
Sir, in some NC files, those coordinate section is empty, and instead of putting those coordinates there, it is those coordinate those latitude and longitude values are present in terms of array
Yeah.
in some
Okay.
in some agency files. So
Mhm.
I want to update those arrays and
Yeah.
update
Yeah.
that
This will
arrays.
update. See, this is an array only, right?
Okay,
See, this is an array only, right?
but
You see?
I don't want to update it in those coordinates section.
You are saying they have data it's another variable as well. Like it's also a variable in the netcdf file.
Yes, sir.
So actually, see, if you will write this as a if you will say dot to netcdf and you will write this data array, right? So the coordinates get written as a variable only. Whatever variable you see after doing ncdum minus h, so that is the coordinates get written as a variable only. But when you read the file, it will show you as a coordinate.
Okay.
Okay.
Yes,
Yeah.
sir.
So is there
Alright.
any other question?
Yeah.
Yeah.
So when you update coordinates, say whatever the earlier speaker said, so after that, all the variable will comply with that new coordinate, right?
Exactly. Yeah. Because
Yeah.
coordinate is like it's like the fundamental thing to this data array.
Yes,
All the
yes.
variables, like it's just got one variable, but if even if in a data set you would have, let's say, these two coordinates only, a particular data set, let's say, has these two coordinates. So if you update the coordinates, it will get updated for all the variables in that data set.
Actually, the earlier speaker raised a very valid question. I also feel the same thing, but I didn't know how to get away with that. Yeah, thanks.
Okay. Yeah. Thanks. So yeah, what was the name of the earlier speaker? Who was it? May I know the name?
Sankirna.
Sankirna. I think sometime we should have at least one offline class. We'll come to know who is. Yeah. So yeah, I think now we are already at 1 p.m. and we have the data science class at 2 today. So I will close this for now. And what we will do is we will